Hello everyone, I hope all of you are doing good, and this is Roshni from LearnoHub, the free learning platform where you can learn anything from anywhere, anytime, absolutely for free. So today's video is the fifth video of the video series on playing with numbers class 6, and in this video we are going to cover some very important concepts of this lesson. For example, we are going to talk about coprime numbers. We are also going to talk about prime factorization. Now these are some very important concepts, so you definitely need to focus. So what are we waiting for? Let's get started. Now that we have learned so much about factors, multiples and divisibility, we will talk about something very interesting, that is common factors and multiples. Now you might be thinking, what does that mean, common factors and multiples? So these are basically those numbers with same factors or same multiples. So do you think that two numbers can have the same multiple? Yes, of course they can have. Now let's do one thing. Let us try to find the common multiples of numbers 2 and 3. So for that, we will first write down the multiples of 2 here, and we will write down the multiples of 3 here. So let's do this exercise. So what do we get? This would be 2, 4, 6, 8, 10. Now we will write considerable number of multiples so that it becomes easier for us to find out the common multiples between 2 and 3. So these are the multiples of 2. Now let us write multiples of 3. So that would be something like this. So now when you look at the multiples of 2 and multiples of 3, so do you find that there are certain multiples, there are certain numbers which are multiples of 2 as well as multiple of 3? The first number that you could identify is 6. 6 is a multiple of 2 and 6 is also a multiple of 3. The next number is 12. It is a multiple of 3 and it is also a multiple of 2. 18, again a common multiple. 24 is another common multiple. So what are you observing? There are certain multiples which are common to numbers, common to 2 or more than 2 numbers. So these numbers are said to have common multiples. So you can say that 2 and 3 have certain common multiples. So what we can say? We can say that common multiples of 2 and 3 are 6, 12, 18, 24. Now since here I have written only till here, if we keep writing more, we will continue to get more common multiples. So this is the range of the common multiples of 2 and 3. Now what about common factors? Do you think that 2 and 3 might have common factors as well? Do you think so? So for that, let us try to write the factors of 2. What are the factors of 2? 2 has 2 factors, 1 and 2, because 2 is a prime number. So it has 2 factors. One is 1 and the other one is itself, that is 2. Similarly, factors of 3 would be 1 and 3. So do you have any common factor? Yes, of course. 1 is a common factor. So 1 is a factor of 2 and 1 is also a factor of 3. So therefore, we would say that common factor between 2 and 3 is 1. So they have just one common factor. Now anyways, we have learned before that the number of factors for a number is always finite. There are fixed number of factors. So it is quite obvious that the number of common factors will also be fixed. But in case of multiples, there exist infinite number of multiples for any number, and therefore the common multiples are also like many. So this is the concept of common factors and multiples. Now to have a better understanding, let us try to find out common factors and multiples of these two numbers, 4 and 8. So how will we do that? So again, in a similar way, first we will write down multiples of 4 and on the other side we will write down the multiples of 8. So it would go somewhat like this. In a similar way, we will write the multiples of 8 as well. So this would be 8, 16, 24, 32, 40, 48, 56, and so on. So now can you find out the common multiples? The first common multiple is 8. The next common multiple would be 16. Next one is 24. Next is 32. Next is 40. And so on. Similarly, 48 would also come here. 4 into 12 would be 48. And so on. So therefore, we can say that common multiples between 4 and 8 would be 8, 16, 24, 32, 40, and so on. So these are the common multiples. Now you might ask, what about factors? So for that we will have to determine the factors first. So what are the factors of number 4? It has 1, 2, 4, because 4 can be written as 1 into 4, 2 into 2, 4 ones are 4. So based on this you can say that 1, 2 and 4 are factors of 4. Similarly, what are the factors of 8? 8 can be written as 1 into 8, 2 into 4, 4 into 2, 8 into 1. So it has 1, 2, 4, 8. So which are the common factors? So basically 1, 2, 4, these are common factors. So you can say that common factors of 4 and 8 are 1, 2 and 4. So in this fashion we can find out the common factors and multiples of 2 or more numbers. So let us try with a set of 3 numbers. So here you are asked to find out the common factors and multiples of 3 numbers, 5, 15 and 25. So here also we will follow a similar approach where we will first write down multiples of each of these numbers. So multiples of 5, then multiples of 15 and then multiples of 25. Similarly, when we write down multiples of 15, it would be something like this: 15, 30, 45, 60, 75, 90, 105, 120, 135, 150 and so on. Again, when you write down the multiples of 25, it starts with 25 into 1, which is equal to 25. Then 25 2s are 50, 25 3s are 75, 25 4s are 100, 25 into 5 is 125. 25 into 6 is equal to 150 and so on. Now looking at these tables, can you identify the common multiples? The first common multiple, now a common multiple would mean that that number should be a multiple of all the 3 numbers. For example, look at 30. So 30 is a multiple of 15, 30 is also a multiple of 5, but 30 is not a multiple of 25. So 30 will not be considered as a common multiple of the 3 numbers. So common means it has to be a multiple of all the 3 numbers. Now let us consider the number 75. The 75 is a multiple of 25, 75 is also a multiple of 15 and 75 is also a multiple of 5. So the first common multiple would be 75. The next common multiple would be 150 because 150 again is present in all of them. Here I have not written till 150, but in this case also 150 is a multiple of 5. 5 into 30 is equal to 150. So therefore in this case we can write the common multiples between 5, 15 and 25 would go somewhat like this: 75, then 150 and so on. And what about the factors? So for factors again we need to find them first. So for 5 there are just 2 factors, 1 and 5. For 15 we do have more factors like 1, 3, 5 and 15. These are the factors for 15 because 15 can be written as 1 into 15, 3 into 5, 5 into 3 and 15 into 1. These are the various ways in which we can write 15. The third number is 25. So 25 again has various factors like 1, 5 and 25. Because 25 can be written as 1 into 25, 5 into 5 and 25 into 1. So these are the factors. Now out of these, which are the common factors? 1 is a common factor and 5 is also a common factor. So therefore common factors between 5, 15 and 25 would be 1 and 5. So in this way we can find out common factors and multiples between two or more than two numbers. So here we talk about a concept of coprime numbers. So what are these coprime numbers? Now before this we had discussed about twin primes. So twin primes were two prime numbers whose difference is 2. But in this case coprime numbers are two numbers having only one as a common factor. That means the common factor between the two numbers will only be 1. Now that itself would mean that these two numbers are prime numbers. Now the best example that I gave you was the number 2 and 3. So when you look at numbers 2 and 3, what are the factors of 2? 1 and 2. What are the factors of 3? 1 and 3. So which is a common factor? 1. So 1 is the only common factor between 2 and 3. So we can say that 2 and 3 are coprime numbers. Now the moment 1 is the only common factor between two numbers, that itself proves that there are chances that these two numbers could be coprime numbers. These two numbers are prime numbers. Now, it is not always necessary that they have to be prime numbers. Now, I will give you certain examples. So, let us consider this example, 15 and 37. So, do you think that both of them are prime numbers? 15 is not a prime number, but when you look at their factors, you see that 15 has 4 factors, 1, 3, 5 and 15. What about 37? 37 is a prime number, so it has just 2 factors, 1 and 37. So which is a common factor? Only 1 is a common factor. Therefore 15 and 37 are said to be coprime numbers. Even though both 15 and 37, they are not prime numbers, but still as a pair they are called coprime numbers. Let us take another example, say 81 and 16. So 81 has a lot of factors like 1, 3, 9 and 81. What about 16? 16 also has many factors like 1, 2, 8, 4 and 16. Now let's compare. So which is a common factor? 1 is the only common factor. So here also these two numbers are coprime. But here also you see 81 is not prime. 16 is also not a prime number. But both of them together form a coprime number. So in case of coprime numbers, it is not necessary that both the numbers have to be prime numbers. They can be prime, they can be composite. So they can be any number. It is just that the only common factor between the two numbers should be 1. So let us quickly look at some additional divisibility rules. If a number is divisible by another number, it is also divisible by each of its factors. Now let us understand each of these with examples. Now let us say we consider a number 248. Now we say that 248 is divisible by 8. Now we have found it by actual division that it is divisible by 8. So as per this rule, that this number will become divisible by all the factors of 8. Now what are the factors of 8? So factors of 8 would be 1, 2, 4 and 8. Now if we say that 248 is divisible by 8, that by default means that 248 will be divisible by 1, 2, 4 and 8 also. So if a number is divisible by a particular number, then the number will also be divisible by all the factors of that particular number. Next rule, if a number is divisible by two coprime numbers, then it is divisible by their product also. Now this is interesting. Now let us take the example of 18. Now 18 is divisible by 2. Yes, we know that. 18 is also divisible by 3. Right? And 2 and 3 are coprime numbers. Why are they coprime? Because they have only one common factor and that is 1. So that is why they are coprime numbers. So as per this rule, if 18 is divisible by 2, 18 is also divisible by 3, such that 2 and 3 are coprime numbers, then 18 will also be divisible by product of the coprime numbers. That means this would mean that 18 is divisible by 6, which is the product of these two coprime numbers. So let us take another example. Let us consider the number 100. So 100 is divisible by 4. 100 is also divisible by 5. And what about 4 and 5? Do you think they are coprime numbers? Yes, because they have only one common factor, and that is 1. So therefore 100 will also be divisible by product of 4 and 5, that is 20. So 100 will be divisible by 20. Next rule. If two given numbers are divisible by a number, then their sum is also divisible by that number. So let us say that we have a number 16. Now 16 is divisible by 8. We have another number, say 32, and 32 is also divisible by 8. So we have two different numbers which are divisible by a same number. Now as per this rule, then the sum of these two numbers would also be divisible by 8. That means the sum of 32 and 16, which is equal to 48, then 48 will also be divisible by 8. So you see, these are some very interesting rules of divisibility, because with these rules you can very quickly decide whether a particular number will be divisible by another number or not, because till now we have told you the divisibility rules from number 2 till number 12. Now you might ask that how do I know if a number is divisible by 12 or not, if a number is divisible by 24 or not. So those are the places where these rules will be useful. So let's say you want to find out if a number will be divisible by 24 or not. So find out if the number is divisible by the factors of 24. So that way, you'll be able to decide whether a number is divisible by a particular number. Rule number 4. If two given numbers are divisible by a number, then their difference is also divisible by that number. So again, let's take an example. Let's say 16 is divisible by 8. We take some other number now. Let's say 56 is also divisible by 8. So now when you look at the difference between 56 and 16, which is equal to 40, so this 40 is also divisible by 8. So if two numbers are divisible by a particular number, then the sum of those numbers is also divisible. The difference of those two numbers is also divisible by 8. So now that we are clear with the concept of prime numbers, we are clear with the concept of factors and common factors and multiples, it is time that we introduce something very interesting concept called prime factorization of a number. So factorization, what is the meaning of factorization? Factorization means writing a number in terms of its factors. So when a number is expressed as a product of its factors, we say that a number has been factorized, or that is called factorization of a number. Basically, writing a number as product of its factors. So let us say, let's take a very common example. Let's talk about the number 8. So 8 can be written as 2 into 4. So 2 is a factor of 8. 4 is also a factor of 8. So we have written 8 as a product of two of its factors. So this means that 8 is factorized, or this is called factorization of 8. 8 is written as product of its factors. Then what is prime factorization? When a number is written as a product of its factors such that all the factors are prime numbers. Now in this case, is this prime factorization of 8? No, because 2 is a prime number, but 4 is not a prime number. 4 is a composite number. So this is not prime factorization, but this is only factorization of 8. So how will we do prime factorization of 8? Now if we write 8 as 2 into 2 into 2, like this also we can write. Now in this case also we have written 8 as a product of its factors. So basically here also we have factorized 8. But now if you see, here all the factors are prime numbers. So we can say that we have prime factorized 8, or this is called prime factorization of 8. So when a number is expressed as a product of its factors such that all the factors are prime numbers, then we call it the prime factorization of that number. So let us take some other examples. Let us talk about a number 54. So 54 can be written as 9 into 6 or 6 into 9. So this is factorization of 54, but this is not prime factorization because neither 6 nor 9 is a prime number. But if the same thing is written as, now 9 can be written as 3 into 3, 6 can be written as 2 into 3. So 54 can be written as 3 into 3 into 2 into 3. So 3 and 2 are also factors of 54. So we have basically written it in the form of factors which are prime numbers. So therefore this is prime factorization of 54. So how exactly do we do prime factorization of a number? So let us say the number is 54. So we start with the smallest prime number. Which is the smallest prime number? It is 2. 2 is the smallest prime number. Now when you divide 54 by 2, what is the quotient that you get? 2 2s are 4, then 2 7s are 14. So 27 is the quotient that you get. So you write the quotient. Now you again divide this by the smallest prime number possible. Possible in the sense which is the smallest prime number by which this will be divisible. So 2 by 2, 27 will not be divisible, but by 3 it will be divisible because 3 9s are 27. Again 9 will be divisible by 3. So 3 3s are 9. Right? Again this 3 will be divisible by 3, that is 3 1s are 3. So you perform this until you get a 1 here. Until and unless you get a 1 here, you continue the process. So once you have done this, then you can write 54 as product of all these factors, that is 2 into 3 into 3 into 3. 2 into 3 into 3 into 3. So this is how we do prime factorization of a number. So you start with the smallest prime number by which that number is exactly divisible. Then you write its quotient and again repeat the process with the smallest prime number possible. And continue this until you get 1. And then you can represent that number as product of the prime factors. So let us look at some examples of prime factorization. So the first example that we will consider is a number 70. Now let us do prime factorization of 70. So which is the smallest prime number by which 70 will be divisible? 2 is the smallest prime number. 70 has 0 in its units place. So 70 is divisible by 2. So what would be the quotient? 2 3s are 6, 2 5s are 10. So it will be 35. Now do you think 35 will be divisible by 2? No, because it doesn't have 0, 2, 4, 6 or 8 in its units place. Will it be divisible by 3? No, because sum of the digits is 8 and 8 is not divisible by 3. So it will be divisible by 5. So 5 7s are 35. Now 7 is a prime number. So 7 will be divisible only by 7. So this will be 1. So you have got 1 here. So how will you prime factorize it? This will be 2 into 5 into 7. So 2, 5, 7, all of them are prime numbers. Let's look at another example. Let's consider a number 450. So this is comparatively a bigger number. So let's start with 2 again. 2 2s are 4, 2 2s are 4, 2 5s are 10. Now 225. This will again be divisible by 5 because we know that a number is divisible by 5 whenever it has 0 or 5 in its units place. So this would be 5 4s are 20, 5 5s are 25. Now this will again be divisible by 5, 5 9s are 45. Now this 9 will be divisible by 3, so 3 3s are 9, 3 will be divisible by 1. So 3 1s are 3. So what do we get? We get it as 2 into 5 into 5 into 3 into 3. So we say this is the prime factorization of 450. So let us quickly look at some of the questions based on the concept of prime factorization. Write the greatest 4-digit number and express it in terms of its prime factors. So what would be the greatest 4-digit number? The greatest 4-digit number would be 9999 because 9 is the biggest digit or the greatest digit. Now 4-digit numbers, so 49, that would be the greatest 4-digit number. So how would you find its prime factors? So perform prime factorization. Will it be divisible by 2? No. Will it be divisible by 3? Yes. 3 3s are 9, 3 3s are 9, 3 3s are 9, 3 3s are 9. This will again be divisible by 3. 3 1s are 3, 3 1s are 3, 3 1s are 3, 3 1s are 3. Now, will this be divisible by 2? No. 3, no. 4, no. 5, no. So, like that, you will see that it is the smallest prime number by which it is divisible would be 11. That is 11 ones are 11, 0, 11 ones are 11. Now 101 is again a prime number. So this will be divisible only by 101. So you can write 9999 as a product of 3 into 3 into 11 into 101. So these are the prime factors of the greatest 4-digit number. Question number 2. The product of 3 consecutive numbers is always divisible by 6. Verify this statement with the help of some examples. Now let us take example. So let us consider example 1. We consider any consecutive numbers. Let's consider 7, 8 and 9. So if you look at their product, what would be the product of 7, 8 and 9? It would be 7 into 8 into 9. So that is equal to 7 8s are 56 into 9, which is equal to 504. So this would be the product. Now this is 504 divisible by 6? Now in order to determine that, we have to see if 504 is divisible by 2. Since it has 4 in its units place, therefore it is divisible by 2. Is it divisible by 3? So we will have to sum the digits, that is 5 plus 0 plus 4, which is equal to 9, which is divisible by 3. Therefore the number is divisible by 3. So we see that 5 not 4 is divisible by 2 as well as 3. Therefore we can say that 5 not 4 is divisible by 6. So this statement is verified. So let us take one more examples to verify the statement. So let us now consider the 3 numbers as 2, 3 and 4. So what is their product? So the product of 2, 3 and 4 would be 2 into 3 into 4, that is equal to 24. So is 24 divisible by 6? We can directly say that yes, 24 is divisible by 6. 6 4s are 24. So with these examples, we prove that the product of any 3 consecutive numbers is always divisible by 6. In which of the following expressions prime factorization has been done? First, 24 is equal to 2 into 3 into 4. Here prime factorization is not done because 4 is not a prime number. 4 is a composite number. 56 is equal to 7 into 2 into 2 into 2. So 7 and 2 are both prime numbers. So yes, in this case prime factorization is done. 70 is equal to 2 into 5 into 7. So 2, 5 and 7, all of them are prime numbers. So here also prime factorization is done. 54 is equal to 2 into 3 into 9. Here prime factorization is not done because 9 is not a prime number. Question number 4. Determine if 25,110 is divisible by 45. So now here you see that we have never talked about any divisibility rule of 45. So how will we determine if this number is divisible by 45 or not? So now here we will make use of the additional divisibility rules that we discussed just now. So what we saw was this 45, we can factorize it. We can write it as a product of its factors. So we can write it as 5 into 9, where 5 and 9 are co-prime numbers. Now sometime back we had learned that if a number is divisible by 2 different numbers which are co-prime numbers, then the number will also be divisible by their product. So that ways, if this number is divisible by 5 and is also divisible by 9, then this number will get divisible by 45 as well. So let us first check the divisibility by 5. So looking at the number 25110, you have 0 at the units place. So we can clearly say that this number is divisible by 5. Divisibility of 9, for that we will have to add the digits. So looking at the sum of the digits, which is 9, we can say that this is divisible by 9 and therefore the number is also divisible by 9. Now, since this number 25,110 is divisible by both 5 and 9 such that 5 and 9 are coprime numbers, therefore this number will also be divisible by the product of 5 and 9, which is 45. So making use of the additional divisibility rule, we could determine if this number is divisible by 45 or not. So we did not do the actual division to find out if it is divisible by 45. Question number 5. I am the smallest number having 4 different prime factors. Can you find me? So it is the smallest number with 4 different prime factors. Okay, so what are the 4 smallest prime numbers? So let us first decide that which are the smallest prime numbers. So first 4 prime numbers. So let's first find out the first 4 prime numbers. So which is the first prime number? Prime number starts with 2. Next is 3. Next is 5. And next is 7. Now it says that it is the smallest number which has 4 different prime factors. Now since the number is smallest, therefore the factors will also be small. That is quite obvious. And it also says that none of the factors are repeated. Like 4 factors and they are 4 different numbers. Therefore we can say that the smallest number would be 2 into 3 into 5 into 7, because this is how you can represent with 4 smallest prime factors such that they are all unique prime factors. So the product would be 210. So therefore 210 is the smallest number having 4 different prime factors.
I hope you found the video useful. If at all you have a feedback or you want to share your experience with us, do let us know in the comment section. If you really like the video, do share it with your friends as well. I will meet you guys very soon with a new video with a new topic. Till then, stay home, stay safe, take care, bye-bye.